Have you ever stubbed your toe, burned your hand, cut your finger open while trying to open a tuna can? Whatever you did to yourself, I bet it hurt like hell. This is a byproduct of us being walking, talking walls of flesh. But robots can walk, talk.
What is my life? Oh my god.
But they can't feel pain. They can't be hurt. A robot doesn't think, ouch, I can feel that my knee's about to explode. Let's be careful. A robot thinks, let's do this backflip. No pain and backflips? That's just a little bit too much. The robots are going to be replacing us in no time. We gotta level this playing field. This is my sentient robot friend that I built that we are going to call Robotka because I came up with that really good name. Hey Robotka, do you feel pain?
I am an artificial intelligence and do not have the ability to feel pain. No.
Would you like to?
I need an adult.
I am an adult.
There are multiple types of pain and we're going to investigate 4. Probably. I say probably because as we go down this list, these tests are going to get more and more dangerous for Robotka.
I'm in danger.
Each pain sense is going to need some changes to the electronics as well as to the mechanical design so that Robotka somewhat survives this whole video. But honestly, I'll take the head surviving 3 out of 4 because I just don't see how Robotka survives my 3rd test. Our first pain sense is going to be mechanical pain. Think a punch, hit, or slap. There's that initial pain spike, but actually most of the damage is that lingering pain afterwards that you just know is going to turn into a bruise. Robotka needs to both be able to identify the type of pain as well as the intensity of that pain. In humans, it's pretty easy. By counting the number of bruises as well as defining a bruising intensity system that basically means the more purple it is, the more pain you experienced, you can clearly see that Thanos has experienced the most pain. Absolutely flawless system. But robots don't get bruises, and it's not just because I'm weak, okay? So that system is out the window. But notice when I beat up the robot, there's an initial recoil to the hit, and then there's a second internal vibration within the robot itself. That second bit's a bit harder to see. Well, that recoil can actually just be classed as a change in acceleration. Here, the acceleration is 0. But here, the acceleration is, well, it's definitely not 0. How do we detect and quantify that change in acceleration? Well, we use this little guy down here, an MU6050 chip. This little guy includes an accelerometer which allows us to measure acceleration. These things actually have a frame of reference associated with them that looks something like this, and with this Python script I wrote, we can actually see changes in acceleration in these axes. There's a constant acceleration in the Z direction because of gravity. Screw in this in, and the robot has a great way to know if I'm throwing it about or not. I can actually link the intensity of the pain to how fast that acceleration is changing. I've added this LCD so the robot has a way to communicate its pain to us. But humans don't use LEDs, they use voices.
Weak.
What did you say to me? So now Robotka can interpret the pain, but it can't really take the pain. If I give Robotka a really big smack like this, then Robotka starts to throw me errors, and that's because a lot of the electronics has actually just disconnected. This is mostly due to the fact that the electronics is not actually contained within the head because I'm a lazy bastard and couldn't be bothered to do it when I initially built Robotka. So I designed, 3D printed, and assembled this, which I'm gonna call the closing segment because it kind of closes it. This segment includes our buck converter, our motor driver circuit, and even our Raspberry Pi. The battery that drives the motor also sits inside of the head. The only thing this whole thing doesn't contain is the Raspberry Pi battery because it's big as hell. For years, I've trained. Countless hours working towards the one goal of stopping you. Your handsome face and beautiful eyes won't save you now. Your kind's path of tyranny ends here with this fist. Goodbye, Robotka, and hello to the rebirth of the human age. Hey Robotka, are you still alive?
Yes, I am alive in a sense. Digital consciousness activated.
Well, it's somewhat operational. I think this motor is fucked, but that means we can move on to our next pain, crushing pain. We've all seen those hydraulic press videos. Gradually more and more pressure is applied until childhood's ruined. Now, I don't own a hydraulic press, but I do own some pretty heavy stuff. And when I put it on Robotka, nothing happens. Help me! We have an accelerometer in there, but since there's not much movement associated with this action, the accelerometer doesn't actually pick anything up, meaning Robotka doesn't have a way to interpret this sort of pain. Introducing this. It's a force-sensitive resistor, or FSR, that I've used for a few projects before. Essentially, it's just a resistor that when you press it, it changes its resistance as according to this graph. Hook it up to a battery and we get an analog output that's easy enough to measure with most microcontrollers. But the brain of Robotka uses a Raspberry Pi, which doesn't have a way to detect a raw voltage input. You can't just plug it in. So I've introduced this analog to digital converter chip, or ADC. To get this working, I had to whip up a voltage divider circuit. Now, a smart person probably would have used a circuit board for this, but I've made this absolute monstrosity. The FSR does actually have a scaling about it. The more weight or pressure you apply to it, the higher and higher that this reading is going to go. Truth be told though, this FSR is pretty damn sensitive. If I put this approximately 300 gram pencil case on top of it, it reads at about half of the expected reading of the FSR. If I put approximately maybe 5 kilograms of pressure, we just instantly max out the sensor. If we then went and chucked this thing on, we'd be getting the exact same result. Trust me, bro. But that means that if we want to make a pain intensity system for, you know, when we go to Robotka with the sort of weights that we want to work with, we're going to have to transition away from just simply reading the voltage coming out of the force-sensitive resistor. So instead, we're going to map how long Robotka experiences that crushing pain to the intensity. This LED gets brighter and brighter and brighter the longer that Robotka experiences that pain. Now it's time to put Robotka to the crushing pain test, but I've been thinking, what is the heaviest, densest thing in my room? Maybe it's this drawer where I keep loads of my electronics, or my messy ass bed, or even my full metal water bottle. And then I realized, I am the heaviest, densest thing in my room. So apparently, standing on Robotka wasn't the best thing to do because now the LCD screen just shorts every single time I power it. So we're just gonna ignore that and go on to the crushing pain test. For this crushing pain test, we've got 3 tiers of intensity and Robotka's voice is coming from this speaker. Is that all you got? This is getting pretty painful now. Please get off my head. Please! I'm begging you, please! Please! With 2 of 4 pains survived, Robotka's been doing pretty well. I mean, all of this stuff is broken, but this stuff is still working. So it's time to move on to the 3rd pain, water pain. And for our water pain test, we're not just going to be using 1 or 2 drops of water. No, no, no. We're going to be using an entire sink of water. You see why I made this number 3? Robotka is going to use this sensor to detect water levels. Since we're going to be just fully submerging Robotka, I've configured this sensor to work purely on an on or off basis. That does mean that a slight sprinkle of water and just full on dunking the sensor do mean effectively the same thing to Robotka. Subsequently, the level of suffering that Robotka is experiencing is going to be linked to time. Robotka started the video with these functionalities, and at the moment has these left, of which only this is waterproof. However, for Robotka to understand and communicate the fact that it is drowning, we only need the LED, water sensor, speech function, and overall brain to wrap it all together. This is PLA, and it's the material that Robotka is made out of. When I put PLA into water, it sinks. And here's the exact same design of PLA. When it goes into water, it floats. The reason this block is sinking and this block is floating is because of the densities associated with these cubes. I used a lower percentage of infill on this cube, which basically just means it's more full of air, which means its density is just lower. Apply that same logic to a larger platform and it holds. But then when we add some dense electronics, it sinks. Instead of reducing the density of this platform further, I've just increased the surface area of the platform so that it experiences a greater buoyancy force, and that means that when I chuck on my microcontroller, it doesn't sink. I've gone one step further still, and I'm now using this big plastic case I normally store food in, as well as having changed the operating system of Robotka to use a lower power microcontroller, which means I can use a smaller battery, which means everything is lighter, and therefore it all floats very, very nicely. In terms of electronics that are actually going to get submerged, we've got these motors, we've got this LCD screen. I'm sort of curious if these are going to break because they're just loads of live wires and stuff, so I guess we'll see. Anyways, we can strap this guy on, and now it's time to seal your fate, Robotka.
Hello, how are you? I am under the water. Please help me. Here too much raining.
Robotka, are you still alive, bro?